for day 5, we are going to continue talking about graphing using vertex form. All of the equations we're going to see today are already put in vertex form. We haven't learned how to convert something from standard form into vertex form. We'll start doing that tomorrow. For those of you in Algebra 2, that's completing the square. We will get there momentarily. But for right now, all of the functions we're going to see are already in vertex form. So let's talk about a refresher about all of our points in vertex form. First off, the plus or the minus is telling us our concavity, concave up or concave down. Our A value is going to be telling us whether our graph is stretched or compressed. Our H value is like our X value, which moves left and right. And our K value tells us how far up or down. So those are the 4 big parts that we're looking at here in vertex form. Additionally, if we know what our H and our K is, how far up, how far down, how far left and right, then we'll be able to tell what our vertex is. So our vertex is always going to be that point, H, which moves left or right, K, which moves up or down. So that's a bunch of good stuff that we can tell just by looking at this equation. So let's take a look at example number 1. In example 1, is this concave up or concave down? We're looking at whether that first sign is positive or negative. And it's positive, so this is going to be concave up. I'm going to skip the increasing and decreasing just for a second. We're going to come back there. But is this stretched, compressed, or neither? That's where I'm looking at this A value. If your A value is equal to 1, or if there's no A value written there at all, then that's neither. Now our vertex is always going to be written as whatever your H value is, comma, whatever your K value is. Oops. So if I look at my equation, I can see that my H value, remember we always need to take the opposite of your H value. So if that says plus 2, then H is a negative 2. And then K is a minus 1. So your vertex is at negative 2, negative 1. All good there. Those are like the things that we're able to pick out just by looking at it. Now what our goal is to graph this parabola. In your quadratics booklets so far, you've been doing rough sketches. There are 2 pages, number 7 and number 9, where we need exact sketches. So this is the process we will do for pages 7 and 9. In order to get an exact sketch, we're going to use a table of values. Ooh, hello. The first thing that I'm going to put in my table of values is my vertex. So negative 2, negative 1 represents my vertex. I'm going to plot that on my graph here. Negative 2, negative 1 goes right here. In a parabola, our graphs are always symmetrical. The left side is the same as the right side. So we get an axis of symmetry that goes through the vertex. So let's draw a line through this vertex. That's my axis of symmetry. If I had to write the equation for that vertical lines always start with x equals, and then whatever the x value is there. The x value there is a negative 2. Our axis of symmetry should always be written as x equals whatever your h value is. So now because I know that it's symmetrical, I want to end up with 5 points, including my vertex. So instead of plugging in 5 different points, I'm going to pick 2 points on the same side of my axis of symmetry so that I can flip them over to the other side and be symmetrical. So I'm going to pick 2 points that are to the right of that x is negative 2. To the right would be a negative 1 and a 0. To get those y values now, all I have to do is plug the x value into my original equation. So this says 1 times x plus 2, so negative 1 plus 2 squared minus 1. That gets me, what am I looking at? 0? Yep. And then 1 times 0 plus 2 minus 1. Oops, squared. 2 squared is 4. 4 minus 1 is 3. So I'm going to plot those 2 points, negative 1 and 0, and then 0 and 3. And then because I have that axis of symmetry, I can flip those 2 points to the other side to make it symmetrical. All of our graphs should end up with 5 points. And once we have our 5 points, we can go ahead and draw in our parabolas. Oops. Any questions on that part? You should be plugging in a maximum of 2 points. We shouldn't have to do it 4 times because we're using that symmetry. All right, now let's go back and revisit the increasing and decreasing part that I missed. So obviously our graph is split in half, right? It's split in half right here at x equals negative 2. We're going to be writing the increasing and decreasing intervals as inequalities for your x values. So let's first take a look at the right side of my graph here. As I am going from this axis of symmetry onwards, is that graph increasing or decreasing? It's increasing, right? It's going upwards. So I would say that on the right side here, we're increasing. What about on the left side, increasing or decreasing? Okay. Yeah, that's it. It's decreasing. This is tricky because you're like, well, it's pointing upwards. Doesn't that mean increasing? But we have to read our graphs from left to right. If I draw an arrow from left to right, that graph is actually going downwards. So that would be a decreasing interval. So now to describe what's happening here, we are increasing for all of the values in which x is greater than this negative 2. So for negative 1, 0, 1, 2, 3, 4, all the way up, that is going to be an increasing interval. So we would say x is greater than negative 2. That's saying for all the x values bigger than negative 2, we're increasing. For decreasing, we would say the opposite. All the values where x is less than negative 2, negative 3, negative 4, negative 5, onwards, we're decreasing. So for all the values where x is less than negative 2, that's a decrease. Does that make sense? One more part here before we're done with this problem is domain and range. So let's look at the bottom here. Domain refers to all of the possible x values in a function. So that's how far left or right does this go. And if you think about a parabola, it's going to keep opening up wider and wider and wider. It might open up wider very slowly, but it is going to open up wider and wider forever. That means it's going to touch all real numbers. We have an abbreviation for all real numbers. If you would like to use it, you could use this capital R with an extra line through it, which means the same thing. Or you could just say all real numbers. Okay, so that's how far left or right we are going. Then I look at the range. Now the range refers to all my possible y values. It talks about how far up or down I am going. I'm going to zoom out here. Clearly our parabola is going to keep getting taller and taller and taller, right? But it does have a baseline. It does have a bottom limit. So the bottom, the lowest it can go, is my y value will touch negative 1, and it won't go any lower than that. Does that make sense? So again, as an interval, we're going, or not as, not as an interval, but as an inequality, we're going to write this as y is all the values that are greater than or equal to, because it does touch negative 1, negative 1. And that's our one problem done. Any questions on that? So you will have to do some stuff like this on your test. It's not nearly as involved on your booklet. For your booklet, you're mostly just doing the table and the graph, and that's pretty much it. All right, flip it over to the other side. The first thing I want us to do is make this a negative. I want to show you what it looks like when it's concave down really quickly. So put a negative in the front, but essentially we're doing the same thing. So we're making this concave down. We're going to skip the increasing and decreasing. We'll come back to it in a second. Is this going to be stretched, compressed, or neither? Based on that A value. A values, Caitlin? Yeah, this one's compressed. A values between 0 and 1 are going to be compressed. Our vertex, remember the vertex comes from H and K. So our H value, the opposite of a positive 2 is a negative 2. The K value is also negative 2. So there's our vertex. And then axis of symmetry, what would that be? You don't have to do too much. Presley? X equals negative 2. It always comes from that H value. X equals negative 2. And you have to write that whole thing out. X equals negative 2. You can't just say negative 2 because it's an equation of a line. Okay, perfect. So that's all the stuff that we can get right away. Let's go ahead and put our vertex on here at negative 2. Right there. And let's start making our table. If you already started doing your points on this table, maybe you noticed, but we're dealing with a 1/2 here. So if I get a number like 3, and I have to take 1/2 of a 3, then I'm going to get a 1.5, which isn't really ideal for graphing. So how do we counteract that? How do we not have to deal with decimals and stuff? When I pick my points, I want to count by whatever this denominator is. So if this is a 1/4, I'm counting by 4s. If this is a 1/2, I'm going to start counting by 2s instead of by 1s. So when I pick 2 points, we start with our vertex. And I'm going to count by 2s to get 2 more points. So 0, positive 2 are going to be my 2 points. Is it wrong if you count by 1s? No, but then you're going to have to deal with those half points and quarter points or whatever it is. To get our y values, let's plug it in. So negative 1/2 times 0 plus 2 squared minus 2. That's 4. Half of 4 is negative 2. Negative 2, this is negative 4. Right? Did I do that right? And then for the 2, same deal. Negative 1/2. 2 plus 2 squared minus 2 equals 16. Negative 8. Negative 10. And we're going to plot those points. So 0, negative 4 goes here. And then 2, negative 10 goes here. If I think about where my axis of symmetry is, I know that I'm going to flip those 2 points an equal distance on the other side. Oh, hello. So here and here. Any questions there? Where is this graph increasing? Remember, we're reading this like a book. So I'm going from left to right. If I start on the left side here, is it going up or is it going down? This one's going up. So this side is my increasing side, even though those arrows are pointing down. So I'm increasing until I hit my vertex, which is at negative 2. And then I start going downwards. So once I start going downwards, that's decreasing. And I'm going to write my inequalities. My increasing interval is all the x values that are smaller than negative 2. So x is less than negative 2. And all my decreasing intervals are all the numbers where x is greater than negative 2. Questions there? Last part, domain. Always the domain is the same, all real numbers. And then our range represents all the possible y values. It goes down forever and ever and ever, but it does have a maximum point. That maximum that it reaches is a negative 2. So this says the range is all the y values less than or equal to negative 2. Good. Any questions on that?